Hello. Cooling demand is rising rapidly. In hot and humid regions like Bangladesh, conventional HVAC systems consume enormous energy. But a greener, smarter cooling future is emerging. Liquid-desiccant-based DEVAP.
We know the Bangladesh lies in a hot, humid climate zone where air contains enormous moisture. This moisture, or humidity, creates a dominant latent cooling load. In fact, almost 70% of HVAC energy is spent to just removing this humidity, or latent load. Moreover, conventional compression cooling systems remove both temperature and humidity mechanically using compressors, an energy-intensive process. One idea is DEVAP, the desiccant-enhanced evaporative cooling, which solves this problem. The idea is removing the humidity first by using a liquid desiccant, then cooling.
To understand why DEVAP is so efficient, we must first understand how it works.
First, hot and humid outdoor air enters the DEVAP system, carrying both sensible and latent heat.
Then, a liquid desiccant absorbs moisture directly from air. This removes latent heat chemically, without compressors, eliminating nearly 70% of cooling energy demand. After dehumidification, the air becomes dry, ideal for efficient evaporative cooling. And only sensible heat is removed using indirect evaporative cooling, without increasing humidity. After that, this cool, dry air is passed through a direct evaporative cooler and slightly humidified if required. This is to reset the humidity from dry zone to comfort zone. And finally, the cool, conditioned air is delivered to the occupied space, achieving comfort with minimal electricity.
Moreover, the indoor air recirculation further boosts the efficiency as it contains low humidity. And finally, to continue this process, the liquid desiccant is regenerated using waste or solar heat. If we compare, conventional HVAC systems rely heavily on compressors to remove humidity and temperature together, where liquid desiccant-based DEVAP separates these processes, removing latent heat chemically and sensible heat evaporatively, resulting in almost 50% energy savings.
Moreover, liquid desiccant DEVAP provides precise humidity control. Unlike conventional HVAC, humidity is controlled independently of temperature, critical for textile quality and worker comfort.
Most importantly, liquid desiccant regeneration requires only low-grade heat. In factories, waste heat from boilers and processes can be directly reused, turning waste energy into cooling. Even solar thermal energy can regenerate the liquid desiccant, allowing DEVAP to operate with minimal electrical input.
Ultimately, liquid desiccant-based DEVAP separates latent and sensible cooling, reduces energy use, and enables sustainable cooling. This is not just an alternative HVAC system. This is the future of green cooling.